Today we are going to go through a provincial examination November, a paper for grade 9 natural sciences. So the next page, the duration is 2 hours and mark allocation is 100 marks. Then we put our instructions there. Then we proceed to section A, which is our multiple choice questions. So the first question reads here, a field force is, right? So we're provided with different options here. So the first one, it says here, is always a force of attraction, right? So it says is always a force of attraction. Let's put a tick on that one. Then the second one, it says occurs only between magnetic and electrical charges. This is incorrect. Then option C says results in an action over a distance between two bodies, which is also incorrect there, right? And then the option D says is the only type of force that is able to change the speed of an object. This is also incorrect. So our correct answer there or option is going to be option A, which says a field force is always a force of attraction. Then we proceed to question 1.2, which says here the electrostatic force between two charged objects is F, right? So between two charged objects is F, right? Then the distance between them is increased. So we're increasing the distance between these two forces. How does the electrostatic force change, right? So basically, the situation or scenario that we're having here, we're having two objects. I can say object A here and also object B on this other end. Then here we're told here the force between these two here is called F, right? So then here after that they say here the distance between them is increased, right? So it means here the distance here, which is more of like the radius there from this one to this one there, is going to be increased, right? So it becomes A and B, they become further apart, right? Then after that now they are asking us, how does the electrostatic force change? Right? So it says A, it increases, right? Option A is going to be incorrect, right? Because now A and B are further apart. It means the force of attraction there should be decreasing, right? Then option B says it decreases, right? So this is our correct answer that says it decreases there because now both these spheres or objects A and B are now far apart. Then the one that says remains the same is incorrect. And then none of the above, also D is incorrect. Then we'll proceed to question 1.3 that says A or N dash rock is derived from a volcanic rock, right? So we've got a mineral is incorrect there. Then I'll proceed to sedimentary, which is also incorrect. Then we also have our igneous versus the metamorphic rock, right? So according to this, I would opt to go for a metamorphic rock there. So this is our correct answer in terms of a dash rock is derived from a volcanic rock. So the most important term there is derived. Take note of derived, right? So that's our correct option there, which is option C. Then I'll proceed to question 1.4. Says the gas found in atmosphere that causes global warming is, right? Global warming is. Then we're having our option D as hydrogen. Hydrogen is incorrect. We scratch that one out. Then option C says our nitrogen, which is also incorrect. Then option B, ozone, is incorrect. The only correct option there is going to be our option A, which says carbon dioxide, right? So carbon dioxide is a gas that is found in the atmosphere that causes global warming. So our answer there, I can just say maybe letter A there, right? Then I'll proceed to question 1.5. So 1.5 says the color of the stars can tell their surface temperature. Which of the following arrangements represents the colors of the stars from the hottest, right? So the hottest to the coolest, right? So to start with, we start the hottest here. Our order is going to be what? The hottest here is going to be the blue, right? The blue is always going to be the hottest, right? And then the coolest is always going to be right there. So it means our option there is going to be blue, white, and red. So our option there, A, is the correct one. Then in terms of option C here, what did they start with? They started with the coolest and then to the hottest there, right? So red, blue, and white. Red, white, and blue. Option B. Option B. That's where they started from the coolest going to the hottest there. So, but in terms of option C and D, it was just like them shuffling the colors around. So our correct option here is going to be our option A. So the hottest is a blue, then followed by white, then the coolest is going to be red there. Then we proceed to question 1.6, which reads, Anna likes baking. She decides to squeeze an orange to get the juice into a mixture. To add flour, state the effect of the force, right? The effect here, they're asking us to state the effect of the force that she applied on the orange, right? So now we want to see the effect of the force, right? So here, what are we told here? She decides to what? To squeeze, right? So if she's to squeeze there, what is going to happen there, right? There is going to be a change in shape. I do believe at first it was more of like a clean sphere or shape like that, more of a circle. Then when you squeeze, it means here, what is going to happen there? It means now there's going to be a change in what in shape there in terms of this. So we're going to squash this, then at the end of the day is going to formulate something like this, right? So it means now our correct option there is going to be a change in what? In shape. So option 1 says changes in movement. There is no change in movement there. Then changes in direction. There is no change in direction. And change in speed. There is no change in speed. So it means our correct option is option C. Then we proceed to question 1.7, which reads, the brightness of the bulb in the electrical circuit below will increase if, okay, how is this that the brightness of this bulb increases, right? Which conditions will make this brightness of the bulb to what? To increase there. So now we're having condition A, which says the wire is made longer. The wire is made longer. This is an incorrect option there. Then the next option says the wire is made thicker, right? So remember, the factors that actually affect the resistance of a wire or a conductor is length of the wire, and also we've got our temperature, and we also have thickness of the wire, temperature, and then thickness, and then the last one, we've got the type of the conductor. We've got the type of the conductor. We've got the type of the conductor. Then I'll proceed to 1.8. 1.8 reads here, which of the following circuit diagrams represents a parallel circuit? So we said our option there is option B at the top. Then it says here, which one of the following circuit represents a parallel circuit, right? So a parallel circuit is a circuit where current has got so many paths for it to go through, right? So if you can look at option A here, it means our current is going to go in this direction. There we can see it follows only one path there. There is only one path for current to flow. Also option B, you can see if current is going this side, there is also still one path for current to flow. Then option C here, you can see there is a division here of current. It means it's going to split into here and also where here, right? So there's going to be splitting of what? Of the current there, right? Like that. So it means this is a parallel circuit. So our option there is going to be option C. That's the correct option there. Then question 1.9, generating electricity by using coal is called what, right? So we've got our option A, which is nuclear power. This is incorrect, right? So electricity using coal, here what we are going to have is our thermal electricity. Thermal means through the use of what? Of heat. So thermal, there is making use of what? Of heat there. So our option there for our multiple choice question, which is the last question for 1.9, is going to be B, right? Then transformation is incorrect, and hydroelectricity is incorrect, as well as nuclear power is incorrect. Then we proceed to question 2, which is our terminology there, right? So we've got terminology. It says give the correct scientific term. So we're looking for a correct, not just a correct, but also a scientific term. For each of the following descriptions, write only the term in the spaces provided, right? So 2.1 reads here, a conductor that opposes the flow of electric charge, opposes the flow of electric charge there, right? This is what you are having. So a conductor is a conductor that opposes the flow of electric charge, right? So now we're supposed to provide a correct scientific term for this one, right? So our answer here in terms of this one is going to be a resistor. This is referred to as a resistor. Then 2.2 says the force by which a planet or another body draws objects towards its center is called what, right? So we're looking at the center. So remember, each and every object is pulled towards the Earth's center, and then that force there is referred to as the force of what? Gravity. So our answer is going to be a gravity or gravitational force. Then 2.3 reads here, a device that opens and closes a circuit, right? So it means this one is a controlling device, right? So it opens and closes a circuit, right? So I think you got that one correct. Yes, it's a switch. It's referred to as a switch. Then 2.4 says here, a molten rock under the crust. So we need a molten rock under the crust, right? So it's molten. So it's referred to as magma. This one, the one that is molten under the crust, right? So 2.5, it says a massive discharge or release of electrons between thunder cloud and the ground, right? So there is a massive discharge of what of electrons there between thunder and the cloud, right? So this is referred to as our lightning, right? So whenever it rains, you see that you hear the thunder and that lightning, right? So it's a massive discharge. That's a massive discharge or a release of electron between the thunder cloud and the ground, right? So this is referred to as what? Lightning. Then rock from which metal can be extracted, right? So where do we extract metals from the rock, right? What type of rock is it referred to as there? So we know we are going to have ore, right? So remember, our ore there is going to have different what metals there or found within it, right? So we're going to say rock from which a metal can be extracted is going to be ore. That's why we have something that is referred to as iron ore. Then we proceed to question 3. It says matching items there. So we're supposed to choose a term from column B. So we're focusing on column B that matches a statement in column A, and then write only the letters A to F next to the question number. For example, 3.1 to 3.5 in the spaces provided in column C. So our answers should be in column C there, right? So we start with 3.1. Says the dredging from form of mining that extracts minerals from loose soil, right? So extracts minerals from loose soil, loose sand there, right? So the dredging form of mining that extracts minerals from loose sand, right? So according to this here, our option should be open cast mining. So open cast mining, which is our option E there. So it means this one is going to be our option E there. Then it says here the boundary between the mesosphere. So it's a boundary between the mesosphere and the thermosphere. What is it called there? The boundary between the mesosphere and the thermosphere is called meso-opposed, right? This is going to be our option there. So option there is going to be our option D for this one, right? So it's going to be our meso-opposed D. Then we proceed to question 3.3, which says the layer of gases held around the earth by gravity. The layer of gases held around the earth by gravity. So what we're going to have there is what is referred to as an atmosphere, right? It's going to be referred to as an atmosphere. And then this means this our option is going to be our option F there for question 3.3, right? Then we proceed to 3.4, which says here the outer gases of a white dwarf that are ejected into space and form an expanding cloud. The outer gases of a white dwarf that are ejected into the space and form an expanding cloud, right? So 3.4 there, our option there is going to be our planetary nebulae, right? Like that. So it means our option there is option C. Then we proceed to 3.5, which is the last one on our matching items there. Type of igneous rock, right? So this is a type of igneous rock, right? So in terms of this, we're going to have our option A, which is referred to as a pumice there. So our option A is the correct answer. Then we proceed to the next question there. So the next question says, question 4, it says section B, question 4. It reads here, learners are provided with 2 glass rods. So we are provided with 2 glass rods, okay? Then it says a rheostat, a retort stand and a woolen cloth, right? So it says they are required to perform an experiment using the apparatus provided. Then the diagram below gives the guides the learners on the steps to follow. Step number 1, we are asked to rub the glass rod. So they are rubbing the glass rod with a woolen cloth, and then hang it in the rotate what stand, right? Then after that, it says step number 2, rub another glass rod and bring it closer. So they rub the first one, and then now they're rubbing the second one, and then what do? We're supposed to bring it closer to the hanging rod on the retort stand. By the way, this is our retort stand there, right? This is our retort stand, and then this one is going to be the first glass rod there that we are having there, and then this one is also going to be the second glass rod that is being wrapped, right? Then it says here to the hanging rod on the retort stand and observe what happens, right? So now we are asked in terms of the aim of this experiment, right? So now we are trying to investigate static electricity, right? Okay, so investigate, the aim is to investigate static electricity through rubbing, like that. Okay, so here I can say to investigate. The aim is to investigate static electricity through rubbing, like that. So that's our aim there in terms of that. Then after that, they are asking us to explain what happens when the rod is being rubbed with a woolen cloth. So when the rod is being rubbed with a woolen cloth, what happens there, right? So it means there is going to be a transfer of electrons, right? So there's going to be a transfer of electrons. There's going to be a transfer. I'm going to say a transfer of electrons. There's going to be a transfer of electrons from the cloth to the rod, from the cloth to the rod, making it negatively charged. Okay, so the other thing I want you to take note of there, whenever there is a transfer, it's always going to be our electrons that are going to be transferred there. So a transfer of what? Of electrons. The electrons are the one that are going to move from from the cloth to the rod, right? So there's going to be a transfer of electrons from the rod to the rod, making this rod to be what? To be negatively charged, right? So then 4.1.3 says here, 4.1.3 says, what will happen when you bring a rubbed rod next to another one rubbed? Okay, what will happen? What will happen when you bring a rubbed rod? So a rubbed rod next to another rubbed one, right? So there, which is hanging on the retort stand as shown in the diagram, right? So now it means here it's going to be what? A repulsion. They will repel, right? They will repel, right? Okay, so there's going to be a repulsion there. So if I can just like explain there what we are having here, so this rod here is negatively charged, and then since we know there's going to be a transfer of electrons from this cloth that we're using to rub here, then these electrons are going to be transferred to this glass rod there, or rod there. So it means this one is also going to be what? To be negative. Then what do we know there? Like charges repel, right? So by like charges, we're referring to the charges that are the same, right? A negative versus a negative. They do not attract, they repel. It means the other one is going to go in this direction, and then the other one is going to go in the other direction, right? So it means here what will happen? So they will repel, right? So it means the one that is hanging here is going to move away, right? So it's going to move away. So it means here, the retort stand, rod on the retort stand, the rod, I can also say maybe the rod on the retort stand, retort stand will move away, will move away, right? So moving away is being repelled, right? From the, will move away from the rod held by hand, like that. Okay, so this is how we're supposed to attempt 4.1.3. Then we proceed to 4.2. It says study the following diagram and answer the questions that follow. Then the formation of lightning can be summarized using 4 steps, right? So represented by in numbers. So we now know it's going to be summarized using 4 steps, right? So represented by the numbers from 1 to 4 in the diagram above there. So we're having those that diagram there, which is 1 until 4 there, right? So 1 to 4 there. Okay, then I will proceed to say in the diagram above, rearrange the statement from A to D below to match the steps 1 to 4 in the diagram. Do not rewrite the statement, use only letters A to D, right? So it reads here, A, the option A 4.21, A reads the potential difference becomes 2 grades negative, right? And positive charges join electrical discharge, creating a flash and hits the ground, right? So creating a flash and it hits the ground, right? So where do we hit the ground there? It means at point number 4 there. That's when it hits the ground. We can see there. So it means our A is going to be option 4 there. Then after that, it says B here. So our A goes with option 4 there, and then our B reads here. B reads ions and free electrons are produced in the air outside the cloud, and positive electricity rises from the ground, right? So it means here I'm going to have my option B as number 3 there, right? So this is going to be option B, right? So it means here this one goes with number 3, right? Then after that, it says C here. C says water droplets, which are particles in the cloud, ionize, right? They ionize, and then ice and water particles separate due to the movement and a friction, right? So this is going to be our option. This is going to be option 2 there, right? So this is going to go with option let's see there at the top, right? So at the top there, that's where we can see here it says water droplets or particles. So we're going to have both of them in the cloud, they ionize, right? So it means here we're going to have our option C as 1. Then after that you're going to have what, D there, which is D. So our D there is going to be like this. So our D there is going to be our option number. So from basically looking at this, it's supposed to be option number 2, right? So what happens there at number 2, it says negative charges accumulate at the base of the cloud and fall to the earth, right? So that's what we're having there. So basically, if I was to arrange them in order there, the first step there, which is number 1, is going to be option C, then followed by option D there, which is number 2. Then our option number 3 is going to be B. Then the last option there is going to be number, which is A, right? So just to match these ones, this is step number, the first step there, then the second step, step number 2, then step number 3, and step number 4. So that's how we attempt that question that is given in terms of a thunder cloud, right? So then mention 4.2, it says mention 2 ways that you can apply to protect yourself against lightning, right? So it means the first thing, you need to stay away from trees, right? Stay away from trees, right? That's the first option that we have. Then also what you can do is to uh seek shelter whenever it's raining to avoid thunder, right? Or lightning there, is to seek shelter. So shelter can be inside a car or a building, right? Shelter in a building, right? Inside a building, right? So there is our option. Then another option that you can add there is that you may need to stay away from high places, right? So it means here I'm going to say stay away from high places, right? So like that. Then 4.3 there reads a spacecraft travel from the Earth to the moon, right? So there from the Earth to the moon. Then calculate the weight of the spacecraft when on Earth. Its mass is 1,485, right? So in terms of this day, we need to know how we calculate the weight, right? So our weight there, I'm going to say our W there is equivalent to, I'm going to write this mass times gravity, which is our acceleration due to gravity, like that, right? So it means the mass of this object is in kgs, which is 1,485. So this is equivalent to 1,485 there. Let me just like redo that one there. So it's going to be is equivalent to 1,485, then multiplied by our gravity, right? Acceleration due to gravity is going to be 9,8, right? So if you can multiply that one there, let me employ a calculator. 1,485 multiplied by 9,8. Yes, I'm going to get a value of, according to my calculator, is 514,553, right? And then in newtons, right? So your weight will always be in newtons, right? So that's how we define or calculate the weight on the moon, right? Of that one, right? So that's our answer there, which is going to be 14,553 newtons, right? Then 5.1 they said study the circuit A, B, C, and D, and then answer the questions 5.1 to 5.1.5 below. Then all bulbs and cells are identical, right? So it means here the bulbs, this bulb and this bulb throughout, they are identical, right? And also we have the cells that are identical. So remember, there is a difference between a cell and a battery. So for example here, for A, what we are having there is a cell, right? Or let me just like draw them on this other end. So if we are having something like this is a cell, right? So it's a cell. But if we have got more than one cell, right? So now it's a combination. If it's a combination like that of cells, we formulate what we refer to it as a battery. So this one is it's a cell. Then when we have something like this, we now have a battery. It's going to be referred to as a battery, like that. Okay, then we're going to proceed to 5.1. It says which circuit has the highest resistance, right? So resistance here, remember they say the bulbs are identical, right? So if we to assume each and every one has got 1 ohm there, 1 ohm, like that, 1 ohm, 1 ohm, 1 ohm, 1 ohm. Then the other thing we need to consider is to see that all these circuits are in series, right? So we know in terms of our resistors in series, we will calculate the total resistance as R1 plus R2, depending on how many they are. Therefore, it means now we're supposed to add all these resistors, right? For example, our correct option there is going to be D, right? So why is it D? If we're to add 1 plus 1 plus 1, we're going to get a resistance of what? Of 3 ohms. Then for this one, because they are identical, it's going to be 1 plus 1, which you're going to get a value of 2 ohms. And then this one remains the same as 1, and then the other one there, like that, right? So because they've got the same resistance there. Then we proceed to question 5.1.2, which reads in circuit B, right? So we are focusing now on circuit B there, right? It says what is the component that is circled, right? Okay, so now remember we started with something like this, and we refer to it as a cell. When there like this, now it's referred to as a what? As a battery there, we can see. So it means the what that is circled there, this is referred to as what? As a battery. So our correct answer there is a battery. So that's what we are having there, a battery. Then I'll proceed to 5.1.3. It says, what is the purpose of the circled component? So it's more of them asking, what is the purpose of the what? Of the battery, right? So what is the purpose of the battery? So the purpose of the battery is to, it is a source of what? Of electrical energy. It supplies electrical energy, right? So I can say it is a source of electrical energy. So it's our power source, basically. It's our power source. Then we proceed to 5.1.4. It says, what is the voltage of each cell in circuit B, right? So what is the voltage of each cell in circuit B, right? So let's look at circuit B. So circuit B, this is the one there. So we're given the a value of how many? 3 volts, right? So if you can look there, it means our battery has got a voltage of 3 volts, and this battery is made up of our main cell. So this is the first cell, and then the other one second, right? So we're having 2 cells there. So it means for us to get the answer there, we're going to say 3 divided by 2. Therefore, it's going to give us a value of what? 1,5 volts, right? So it means each cell has got a voltage of what? 1,5 volts. Then we're going to proceed to question 5.15, which reads, in which circuit will the bulb or bulbs be the brightest, right? So where there is going to be the bulbs, they're going to shine brighter, right? So where do we actually have this one? So let's go ahead and check there. So it's going to be our option again. It's going to be our option B, right? Then the reason behind B, okay, we're going to say B there, right? So why is it B? It's because here, what we are having here is that we've got less resistance, and the voltage that is being supplied is actually what? Higher. Therefore, if it's higher, it means now we are expecting to be having more current that is going to flow through the here. Therefore, it means our bulb there is going to what? Burn brighter, or be the brightest. So our option there is going to be option B. Then 5.2 says, mention 2 factors that can influence the resistance of a resistor, right? So we've got different factors that can affect this one, right? So it means I will start with the length of the conductor, right? So I can have the length of the conductor. So as my first option there, length of the conductor, length of conductor, okay? They're saying mention 2 factors that can influence the resistor of a resistance of a resistor, right? So in terms of the length of the conductor, we are going to say the longer the wire, or the longer the conductor have, it means we will have a higher resistance. If the conductor is longer, you're going to have a higher resistance, right? Then also the next thing, it means if you're having a shorter conductor, the resistance is going to be less. So the next factor there is going to be the temperature of the conductor. I'm going to say temperature of the conductor, temperature of the conductor, temperature of the conductor. So in terms of this, to explain the temperature of the conductor, we're going to say the hotter the conductor, the higher the resistance, right? So if you increase the temperature of the conductor, resistance also increases. And then we're also going to have another one, which is the type of the material, right? So type of material, right? So to explain the type of material, we're saying here we're going to say different materials, right? So we've got different materials, different types of conductors, and because they're different materials and different conductors, therefore they've got different what resistances. And then the fourth one that I'm going to mention is the thickness, yes, thickness of the conductor, of the conductor. Okay, so now to explain this one, it says the thinner the wire, the higher the resistance, right? So it means if your conductor is thicker, it's going to have a what? A lesser resistance. Then we're going to proceed. So here we only asked to mention 2 vectors. Proceeding to 5.3, it says here, describe how each factor you choose which was in 5.2 affects the resistance of the resistor, right? So it means now from those there, I can now go ahead and say to explain, maybe I already explained. Okay, so I would just like take maybe temperature, describe how each factor you chose. Okay, so I would just check temperature. So allow me to say T in degrees Celsius, which is our temperature there. I'm going to say the hotter, the conductor, the higher the resistance, the higher the resistance. So this is what we're having. Then another one maybe I can actually like explain is the thickness of a conductor, right? So thickness, therefore, if we were to choose this one there is an option, thickness of conductor. Okay, so if the conductor is thicker, we are going to have what? Less resistance, right? So if its conductor is thicker, we are going to have a less resistance. The thinner the conductor, the higher the resistance. 5.4 reads, study the levels of an electric stove in the diagram below. Give the correct scientific term. So we're looking for a correct scientific term or word for each of the descriptions. Write only the answers in the spaces provided. So they provided us with the space there. So now we're having the 5.41, which reads a safety device inside the stove to prevent an overload, right? So it's a safety device, right, that prevents an overload, right? So this one we're going to refer to it as a fuse, right? So it prevents overload, right? Once there is overload, it actually burns, and then if it burns, it means now it's going to cut off the power supply, hence protecting our appliances. Then 5.42, it says a device inside the knob to set the plate on high or low temperatures, right? So now we're having 5.4.2 there. It means here is going to be a variable resistor, right? So it's a variable resistor. So it's the one that is used in terms of a device inside the knob to set plate higher or lower temperatures, right? So it's referred to as a variable resistor. At times they can refer to it as a rheostat. So it can be referred to as a rheostat. Okay, then I'll proceed to 5.4, 5.3, 5.4.3. It says a small device that lights up to indicate that the plate is switched on, right? So this is more of what? A light bulb, right? So it's a light bulb, or you can say an LED, which is a light emitting diode there. Then we proceed to 5.5. State an example of a safety device that can be used in our houses. So state an example of a safety device that can be used in our houses, right? So in terms of this here, we have got a surge protector. A surge protector, we can see usually they usually buy it for our refrigerators and stuff. Then we can also have maybe a fuse. They remember I said a fuse, it burns out and then it protects our what our appliances. Then we also have a circuit breaker, right? So whenever you trip it, it means there is no electricity that is going to what to be flowing. Then we proceed to question 6.1, which is here two identical cells, two different light bulbs, and connecting wires are connected as shown in the diagram below. Then bulb X has a higher resistance. So this one X there has got a higher resistance than bulb Y, right? So it means I can just say X is greater than Y, right? X is greater than Y, not less than there. X is greater than Y. So X is greater than Y. So the potential difference across the two cells is 3 volts, right? So potential difference, remember, it refers to the same thing as the voltage there. So we're having our voltage there. Then it says name the device used to measure potential difference, right? So if you now know potential difference is voltage, what do you use to measure your voltage? You use a voltmeter. So I'm going to say our correct answer there is going to be voltmeter. meter. So voltmeter like that. Okay. 6.1.2. If the current that flows in AB is a 1 amp, right? So if the current that is flowing from A to B there, from AB there, right? So if we were to put our ammeter there, right? And then we're having a reading of 1 amp like that, then it says, will the current that flows through part E and F here, right? So if we were to put another ammeter there, are we going to read the same there of E or F is more or less than or equal to 1A, right? So our answer there is going to be equal to, right? So equal to is going to remain the same, right? So remember, this is a series circuit, and in a series circuit, there is only one path for current to flow. And then from that one path there, your current remains what? The same throughout, okay? Then 6.1.3 says, if the potential difference, which is your voltage, across bulb X is 2 volts, right? So here we're having across X there, if I can put my voltmeter like that. So remember, our voltmeter is connected across. So it's going to be there, and then we're told it reads a voltage of what? Of 2 volts there. So I'm going to put something like that and then say this is 2 volts, right? So calculate the potential difference across bulb Y. Show your workings, right? So in terms of this there, we're going to say our voltage here is equivalent to, so remember, the resistors in series, their voltage what are potential difference dividers, right? So it means now we're going to add this one and add that one there, right? So it means it's going to be a voltage that we see at point X there. I'm going to use an X there is equivalent to voltage there at what? At Y. Also, I'm going to say V at point what? Y. Then after that, now I'm going to say let's say, for example, let's start with this one there, which is our voltage there. We're given a total voltage of what? 2 cells is 3 volts. So I can just say VT, right? So let me use VT, which is our voltage total, is equivalent to VX plus VY. Oh, not is equivalent to there. Sorry. I'm supposed to say plus there. We're adding these two. Remember, potential difference, resistors in series are potential dividers, right? So it means here, if I had to substitute there, our voltage is 3, we're given there, which is our total voltage. Let me just like maybe circle it there. So the potential difference across the 2 cells is 3 volts like that, right? So is equivalent to the voltage at X there. The voltage at X there we're told is 2 volts, right? So I'm going to say 2 plus our VY, right? So to make VY the substitute formula, what am I going to do? I'm going to take this one this side. So I'm going to say 3 minus 2 is equivalent to VY, right? So our voltage at Y there. So our answer there is going to be what? So I'm going to say, therefore, VY is equivalent to a voltage of 1 volt. So remember to include your units of measurement there. I will proceed to question 6.14, which reads, if the light bulb explodes, right, what will happen to the light bulb Y? Then explain your answer, right? So this Y there, this Y is going to go off, right? So this one will go off. The reason being that this one is no longer functional there. So this one now acts as a what? As a switch, right? So it's now preventing the current what? To flow, right? So it means here, if bulb X blows out, what happens to Y, right? So bulb Y will go off. Bulb Y will go off, right? So take note, that's the reason why our houses, whenever they're connecting their lights and stuff, they are not going to be connected in series, they are connected in parallel, because if one burns out and you have connected them in series, they act as a what? As a switch, right? So but why we go off? Because they are connected in series, right? So if they were in parallel, current was going to find an alternative route to reach to that other part, right? So in terms of this, like, so I can just say Y bulb X bulb X as a switch. So once it burns out there or it blows there, it means now the switch is off. Then 6.2, we're given a diagram. It says consider the following picture of an electric circuit. So use the information in the picture above and draw the corresponding circuit diagram there. So what we are going to have there, these are two bulbs. There is a cell there at the top there. So to represent a cell, remember we said it's one line like that, right? Then after that, now what do we have there? We have got two bulbs, right? So I'm going to represent those two bulbs. They are connected like this there. I'm going to say the first bulb there, and then it's connected to this other like that, right? Then after that, now I'm going to proceed again, go down there, and then go down there where we are going to have another bulb there, right? So this is our bulb there again. Then after that, now what you're going to have is our voltmeter. So our voltmeter, you can see, is connected across that bulb there. So I'm going to have my voltmeter as V there, which is going to be connected across what? Our second bulb. So that's how we represent our drawing there, right? Then 6.2.2 says, what will happen to the voltmeter reading if the bulb marked X fuses, right? Write down increase, decrease, or remain the same, right? So it means here is going to remain the same. The answer is remain the same. Then we need to explain why it remains the same, right? So it says provide a reason why a voltmeter is always connected in parallel in a circuit. So it is connected in parallel because it has got a high resistance, right? So voltmeter is a high resistance like that. Okay, so it has got a high resistance connecting in parallel. So if you are connecting it in parallel, it's in a parallel. What does it do? Parallel. It has got an impact. We lower the total resistance, right? We lower the total resistance. So if our resistance is low, it means more current is going to flow, right? We lower the total resistance in a circuit. So I'm going to say in a circuit like that, right? So that's our answer there. Then I will proceed to question number 7 there. So in terms of question 7, they were given a question that reads the electricity voucher below was bought at a supermarket. The voucher shows the number of electricity units bought and how much money was spent to buy these units of electricity. How many units were bought with 30 rands, right? So it means how many units were bought with what? 30 rands. So we're given the total amount is 30 rands. Then they included their tax there and all, right? So here receipts then the credits there is 1190, or total units there is 1190 kilowatts per hour, right? So kilowatt hour there. So how many units were bought with a 30 rands, right? So for us to look at this, the total units there that we have there, this is the answer that is given there. So I'm going to say 11,90 kilowatt hour, right? So, or if I wanted to put it in units, I could have said just 11,90, 11, I'm going to say, 11,90 units there. So these two are all what? The same there. They are considered as being correct. Then use the information on the voucher to determine the cost of electricity per unit, right? So they are asking the cost of each unit there, right? So how much did we buy there? We bought electricity for 30 rands. Therefore, it means we are going to say price per unit is equivalent to 30, or I can say price per unit. To write it, per unit is equivalent to, so we bought like for 30.00, it was 30.00. Then I'm going to divide by the total units that we got there, which is 1190. So divided by 11,90, which is equivalent to, so let me employ my calculator. 30 divided by 1190 is giving me a value of what? So I'm going to put this one in rands, which is 2,52. So it's 2 rands and 52 cents per each unit, right? So 7.13 says use your answer in question 7.1.2. So we are building up upon this answer there that we got to determine how much it will cost to keep a 60-watt bulb on for 24 hours. Remember cost, so we're already given a formula there. So it means if we're given this formula, what I'm going to do there is to just like make use of this one. So it means times time there. So your power there is going to be what your power there, your power there, your power there. Where is it? It says the power 30, like that, like that, like that, like that. So what are we given there? Oh, we're given a value of what? Of 60 watts there, right? So it means now we're supposed to convert that one there, that watt there. So if we are to convert it, you're going to get a value of what? 0, 0.06 and then I'm going to say multiplied by the time that we're given there, which is 24 hours, and then multiplied by the unit price that we got there at the top, which is 2.52, 2.52. So if we are to do our math there, we're going to get a value of what? Let me make use of my calculator real quick there. uh Okay, so our answer there is going to be a value of 3 rand 63 cents. So it's going to be 3.63 cents, 63 cents. Let me erase and rewrite that one there. So it's going to be 3 rands 3.63 cents, right? 63 cents. So this is what we're having there, right? In terms of this 0.6 there, right? So we needed it to convert it, right? So to convert it there, you're supposed to say 60 divided by 1,000, right? So if you convert it, you're going to get a value of what? Of 0.6 there, kilowatts hour. So remember, kilo means 1,000, right? So now we're going to proceed to 7.1.4. It says name one way in which consumers can reduce their electricity bills, right? So for us to reduce our electricity bill is to use maybe solar geysers, okay? Use install a solar geyser, install a solar geyser. Okay, so instead of using electricity, you can just use solar geyser. Then also let's use energy saving bulbs. Use energy saving bulbs, right? So these are some of the answers that you can make use of, or you can also say switch off the electrical appliances that you are not using, right? So then we proceed to 7.2. It says consider the electricity generated in a coal power station versus the electricity generated in a nuclear power station, right? Name one similarity between the two power stations, right? So between the similarity between a nuclear power station and N versus an electricity generated, consider electricity generated in a coal power station, right? So these are the two that we're comparing there. Coal power station versus a nuclear power station. And then we're asked to indicate one similarity, right? So the similarity is that they both use what? Steam to rotate turbines. They both use steam to rotate turbines like that. Then we proceed to 7.2.2. It says name one difference between the two power stations. Like name one difference between the two power stations, right? So I can state that in a nuclear power station, right? Power station in a nuclear power station, then the heat source is from, the heat source is from nuclear reaction. Nuclear reaction. Okay, that's one difference there, right? So if you wanted to write in terms of a coal power station, you're going to say a coal power station. It is from what combustion of what of heat, so or of coal there, right? So the heat source for a coal power station is from what from the combustion of what of coal there. So by combustion there, we're referring to what to the burning of what of coal. Then we proceed to question 8 says the interaction of the ethosphere spheres there right there. So the interaction of the ethospheres, then the diagram below illustrates the interaction of the spheres of the earth as a complex system, right? So that's what you're having there according to your diagram there. It says describe the interaction between the different spheres in question 8.1.1 to 8.1.3. So it says volcanoes erupt shooting gases and dust into the atmosphere. Okay. Volcanoes erupt, shooting gases and dust into the atmosphere, right? So here, what we asked to do to describe the interaction between the different what spheres, right? So here it means here what we have there, we're going to say interaction between spheres here. It means we are going to have a lithosphere, a lithosphere interacts with the atmosphere, right? And the atmosphere atmosphere. So this is the interaction that we're having there. Then here, water evaporates from ocean, becoming vapor in the atmosphere. So in terms of this here, we're going to have the atmosphere versus the hydrosphere, atmosphere and hydrosphere, like that. Then 8.1.3, plants derive water from soil. Animals use water to sustain what? The life, right? So this it means is an interaction between lithosphere, lithosphere, and lithosphere and hydrosphere, hydrosphere. Like that. Okay. Then we proceed to 8.2. Says complete the table below by filling in the tables in the labels A to E. So we've got the type of rock there, the formation, presence of crystals, and an example. So we're having A there, which is our magma, is that has cooled, right? So a magma that has cooled there. So it is referred to as what? Complete the table below by filling in the labels A2 to E, right? So type of rock, and then here, and then B, and then metamorphic, right? So here, in terms of this, we are going to have here our A type of rock there is going to be our igneous rock, right? So our A there, I'm going to say igneous rock, right? So this is what you're having in terms of our A there. So type of rock, igneous rock, and then it says here uh, B, under B, they were going to have what we refer to as sedimentary rock, right? So we're going to have our sedimentary rock for B. So igneous rock, then B there is going to be our sedimentary rock. Then our C there is going to be having a weathering, right? So it says magma, then cool, then C there, we're going to have what? Weathering there, right? So we're going to say weathering of igneous rock. So weathering, which is the breaking down, right? Weathering of igneous rock, igneous rock, okay? Then compaction and what cementation, right? So there's also going to be what cementation of this one there, right? Then after that, now what we have there, D, option D there. So after D there, we're going to have high pressure. So D is high pressure, D high pressure and extreme heat, high pressure and extreme heat of igneous and sedimentary rocks. Sedimentary rocks. Like that. So that's what we're going to have there. Then our E there is going to be our sandstone Sandstone, sandstone there, sandstone there, or it can be our limestone. Okay, then I'll proceed to 8,3. Rocks on the surface of the earth are weathered to form smaller particles. Mention any three important factors that influence the process of weathering, right? So now we've got heat. Heat is an example. So here our temperature, heat or cold. It can be cold, it can be water, it can also be what? Be wind, like that. So these are three important factors. So you can choose any three from these that can influence the process of what? Of weathering. Then we're going to proceed to 8,4. So 8,4 here reads here, study the diagram below and answer the questions that follow. What is the name of the structure represented in the diagram, right? So we can see there we're having our plants there, and then there is some sort of roof there, and then everything is seems like there is the energy once it goes through in here is going to be trapped, right? So if it's like this there, we refer to it as greenhouse. So this is a greenhouse. Then 8.4.2, which form of energy is trapped inside the structure? So it means heat is going to be trapped there. So, or you can just say it's radiant heat, radiant energy, right? So energy through radiation, right? So which is our heat there. So radiant, there is a D there. Okay, so 8.4.3 says which layer of the atmosphere resembles the glass pans in the structure above, right? So the type of sphere that we're having here is referred to as a troposphere. So it's going to be a troposphere. Then 8.4.4 says which natural process produces the gas found in the which natural process produces the gas found in the atmosphere that absorbs or re-emits energy radiated by the sun. So that's our 8.4.4 there. So it's going to be the same as the greenhouse effect, right? So 8.4 and 4, greenhouse greenhouse effect. Then what is the advantage of this natural process for life on Earth? What is the advantage of this natural process for life on the earth, right? So it means here earth becomes warm, right? So earth becomes warm because of this. Earth becomes warm, right? So warm like that, and becomes habitable for life because there is warmth. It means it becomes, and it becomes habitable for life, right? For life. So because there is warmth, we are able to live in it, right? So then question 9.1 says the pie chart there. So now we are the section there, impact of mining on the environment. So the pie chart below shows the number of different mining projects in South Africa that were ready to start production in 2017, right? So we're given the number of different mining projects in South Africa there, and then other minerals, diamonds, like that, all those, right? So they're saying use the information provided in the pie chart to answer the following questions, right? So we're going to use the pie chart to answer the questions that follow. It says, which mining project is the largest among the possible new mines that were ready for new production in 2017 there, right? So if we can look at this one, which one has got highest there? So yes, the highest there is going to be our coal there, right? So it has got like the lion's share there, right? So it's going to be coal there, which is 47. So I'm going to write coal here. Then we proceed to the next one. It says calculate the percentage of the number of possible new gold mines, right? So there, what do we have there? We're going to say, how many do we have? For gold there, the possibility there is 41, right? So we're having 41 there. So we're going to say 41 divided by, so I'm going to say 41. So as a percentage, so it's going to be 41 divided by, okay, so if we're to add all these ones, what are we going to get there? So we're supposed to add 26, this 26, 9, 9, 16, 47, and 44, right? So let's just like quickly do the math there. If I'll start with 44 plus 47 plus 16 plus 9 plus 9 plus 26, a total of what? Uh, plus 41. So we're going to get a total of what? 192, right? 192. So it's equivalent to 41 over 192. 192, then I'm going to multiply it by 100 to formulate a percentage there, right? So it means here I'm going to say 41 divided by 192 multiplied by 100 is equivalent to, therefore I'm going to get a value of what? 21.4. I can say 21.4%. So our answer there is going to be 21.4%, right? So take note there, we are supposed to add all these values there, right? So all these values there, we're supposed to add them. Then after that, we are going to say that a 41 there, which is gold there, all over the total number. Then to convert to a percentage, you multiply by 100. Then we proceed to 9.1.3. It says, where does mining take place in an open cast mine? Where does mining take place in an open cast mine, right? So it has to be on the surface. If it's open cast, so it means it's on the surface. So on the surface, like that, because it's open cast, right? Then we proceed. 9.1.4, it says, is iron ore a mixture or a compound, right? So is iron ore a mixture or a compound, right? Then provide your answer. So it is a mixture. I'm going to write here a mixture. A mixture. Then after that, I'm going to say, since it's a mixture, why is it a mixture? So it's because it contains that consists or contains that contains or consists, you can say consists also of different different minerals. Okay, of different minerals, like that. Okay. Then we proceed to 9.1.5. It says, name and discuss one way in which mining can impact the environment. Name and discuss one way in which mining can impact the environment, right? So it means here, in terms of this, I'm going to say removal of plants. There's going to be removal of plants, right? So you need to clear the land, right? So removal of plants. So removal of plants there. So if you remove the plants, then what happens there, right? And then results in habitat loss, right? Results in loss of habitat. Remember, there are some animals that actually live within these plants, right? Removal of plants results in loss of habitat for what? For animals, right? So because we are clearing the land for animals, like that. Okay. Then we proceed to question 10 there, which is our last question there. So question 10 is there. Birth and life and death of what? Of stars. Then explain, they're saying explain what happens in the nuclear reactions, right? So here it says there's going to be changes of light elements, changes in light, changes in changes light elements. Okay. Here there's going to be a change in light elements into heavier elements. Into heavier elements, reducing a lot of energy, reducing a lot of energy in the process. Like that. So then question 10.2, why is it not possible for light to escape a black hole, right? So this is because of gravity. The gravitational pull, gravitational pull is too strong. Is too strong. Okay, with that being said, we have got to the end of our question paper. Then thank you for watching.